So in this part, I'm going to build on some of the pitfalls of the short-term memory model, that it was a box that didn't really think of information in different kinds of versions, so visual information, auditory information, and so forth, the whole notion of codes. So they took that to heart, and researchers have taken those ideas and sort of reformulated a more appropriate model for memory that we use for the shorter term, and this is called the working memory model. And this is a model that has received lots and lots of support over the years, very well established processes within that model, and it gives us a good sense of how memory, as we're dealing with active tasks, actually works. So the working memory model in some ways is just a modernized version of short-term memory, and it was updated by the main person was Alan Baddeley. If you want to look this up, you'll see there's a lot of information on this model because it's been tested in a lot of different contexts and so forth. But he kind of took the idea of short-term memory and then modified it so that it became the working memory model that we'll see. And what I like about this model, and what most people like about this model, is that this model is really focused on processes as we're dealing with processing information, rather than so much with, boxology of, short-term memory is one box, long-term memory is another box, and so forth. So instead, this is really much more actively engaged with the kinds of tasks that the memory system is being used for, and then it asks questions about what kind of processes are at play when we deal with different kinds of information. So the working memory model, if you want to define it, has a couple of components to it. So the definition is right here: limited capacity system for temporary storage and manipulation of information for complex tasks such as comprehension, learning, and reasoning. That's a mouthful, so let's break that down for a second. A limited capacity system. That means it's not possible to put infinite amounts of information in working memory. Just like we saw that short-term memory had limits, right? 7 plus or minus 2 units of information. The same is true for working memory. Then the next part, for temporary storage, so meaning this is not long-term memory. And this is interesting, manipulation of information for complex tasks. So in other words, this is a very active system where we're using information to actually be able to comprehend things, learn things, and reason about things. So that's different. It's very much focused on active engagements with actual tasks. Now, the limited capacity part here is also interesting when we look at it more closely. So in short-term memory, there was just this overall capacity. In the working memory system instead, there are actually different components within the model that handle different kinds of information. And these different components are relatively independent of one another. So let me first show you a picture of the model, and then I'll talk about what these different components do and the logic behind this. So here's what the model looks like. There's 3 parts, and 2 parts are really the functional parts, and then the third part integrates information from both of those other 2 parts. So the first part is the phonological loop, and as the word suggests, this deals with phonological information, meaning language and hearing. And on the other hand, there's the visuospatial sketchpad, which deals with visual information and spatial reasoning. In the middle of that, you see that there's a central executive, and that's a system that actually integrates information from those 2 different subparts and coordinates it, sends certain tasks to one system or the other system, and so forth. Now, the phonological loop and the visuospatial sketchpad, as I already said, have their own limited capacities. And that's important because it yields several different predictions. First of all, if these 2 systems have separate components, then depending on which 2 tasks you're engaged in, they can either tax the same system or they can be taxing a different system. So the idea is if you have 2 tasks that either both fall on the phonological loop or they both involve the visuospatial sketchpad, they'll be hard to perform together because they will tap into the same limited capacity pool. If, however, you're trying to combine a visual task with an auditory task, then that auditory task would involve the phonological loop, the visual task would involve the visuospatial sketchpad, and you would be more successful at combining those kinds of tasks. So that's one basic idea, and we will get to actually testing that and seeing what the evidence is for that notion. Working memory is different from short-term memory, as I said already, because it's a more active system. It's not just for transferring information into long-term memory. It actually helps us with manipulating the information to be able to carry out complex tasks. And as I said, it has these three parts to it, with the visuospatial sketchpad, the phonological loop, and then the central executive in the middle. I'm going to talk about each of those parts in a little bit. But first, so this is a bit of repetition, right? I already said this. Here's a key idea. If, let's say, you're reading a book, right, you can convert the words you're reading into auditory information as if you're listening to yourself read, and that part would then be handled by the phonological loop. On the other hand, if you're doing a puzzle, that's a visuospatial skill, so that would be handled by the visuospatial sketchpad. Right? And these two tasks would involve the different components, and they would tap from different limited capacities. Now, there are also tasks, of course, that you can partly do with one system and partly with the other system. So, for example, if you're driving in a car and you're thinking about where you need to turn, and there's a passenger next to you who tells you, go left at the second corner, then hearing that sound from the passenger would be processed by the phonological loop. The spatial concept of where you're going would be handled by your visuospatial sketchpad, and then the central executive in the middle would integrate that verbal and visual information so that you actually know where to go and you're successful at performing that task. So that's some of the core notions behind the working memory model. And now I'm going to talk about some of the specific components in the next video.